So in this mini tutorial we're going to look at how to rearrange equations. If we imagine a simple equation like a plus b equals c. When we want to rearrange equations, it's often to try to isolate one particular term, often an unknown term, by itself, so that we can then work it out by feeding in known values. So let's imagine in this case we want to isolate a by itself. And at the moment, as written, there's also a plus b on this side of the equation, and to isolate a we need to get rid of the plus b. When we rearrange equations, we just have to imagine that we have the mathematical operators operating in pairs, basically. So we have plus working as a pair with minus, and multiply and divide. And if we want to get rid of or reverse a plus, as in the case here, we perform the opposite, a minus, as shown here, the other half of the pair if you like. If we want to get rid of a multiply, we do the reverse. So we look at, for its pair, the divide, and do that instead. So in this case, we're trying to get rid of plus b, so eliminate it from the left hand side of the equation. So we do the opposite, we subtract b. So we can write a plus b minus b equals c minus b. The important thing to notice here is that we're doing exactly the same thing on both sides of the equation. So we've subtracted b from this side, we're also subtracting b from this side. And then the plus b and the minus b cancel each other out on the left hand side. So that we're then left with a equals c minus b. And that has isolated our unknown term a by itself as desired. We can do the same kind of thing with different operators. If we imagine in this instance we have a multiplied by b equals c, and again we want to isolate a by itself. This time we need to reverse the multiplication. We look for the pair here, the multiply and divide. That's the division that we want to do this time. So this time we are saying a multiplied by b divided by b equals c, and again we're doing the same thing on both sides of the equation, c minus b, and again the multiply by b is cancelled out by the divide by b, so that we're successfully left with a equals c divided by b. We can do the same thing even if we have more than one operation going on one side of the equation. So if you imagine we've got an expression like ab plus c equals d, all we do is work through one step at a time. So let's say that we're trying to isolate a again. First of all, let's get rid of the c from that side of the equation. So we subtract the c, ab plus c minus c equals d minus c. And again, the plus c and the minus c cancel. And now we're going to divide through, because this is a multiplication here. We want to reverse that. So we say a, b. So we're dividing by b equals d minus c again. Doing the same thing on both sides of the equation. So that cancels out, and we're left with a equals d minus c over b. And these kinds of manipulations or rearrangements of equations are very helpful when we're thinking about chemical quantities, chemical equations and chemical numbers. So for example, in chapter 5 we see the expression that the amount of substance in moles, so written by n, is equal to the concentration times the volume. And we can rearrange these equations in just the same way if we want to isolate an unknown term. So for example, if we want to know what the concentration is when we know the amount in moles and the volume, we want to isolate C. We need to get rid of the multiply by V term here. So again, we perform the reverse, which is a division. So we say n over v equals c times v over v. And again, the multiply and the divide cancels out, and we're left with the expression n divided by v equals c.